Using the method learned in class, how would you write the chemical formula for oxalic acid? So to better understand this problem, we can take a look back at our textbook and define some things to help us reach our answer. So what we're looking at is an acid, and it says that acids are easy to identify by the hydrogen that starts the chemical formula. So that right there tells us that hydrogen will be in the beginning of the chemical formula. And it says there is a reason for writing the hydrogen at the beginning of the chemical formula. In a chemical reaction, a hydrogen ion may dissociate, which is fall off or break apart from the compound. Though not all acids are ionic by nature, the ability of hydrogen ions to dissociate from the compound means that acids can be viewed as being composed of cation and anion parts. The cation of an acid is always the hydrogen ion. So our chemical formula is going to be in two parts, this hydrogen being the cation, this being the anion. Now, let's go back one more time. It says that acids present in two ways, binary and oxyacids. We are looking at an oxyacid that has hydrogen bonded to a polyatomic ion containing oxygen. Our chemical formula does contain oxygen. And let's just define a polyatomic ion. It is a charged common grouping of atoms that have a designated name. Now, our professor gave us a nice summary of ions sheet that give us those new names for polyatomic ions. This right here is going to be the other half of our chemical formula, which is oxalate. Now, how did we get to this name, oxalate? Let's take a look over here for our rules of naming ions. It says that for polyatomic oxyanions with oxygen in it, the one with the most oxygen atoms is going to change the suffix from IDE to ATE. So since our oxalate has 4 oxygens, that's what's going to make it change to ATE at the end, ending suffix. So if we look down here for acids, some rules says that generally identified by a leading H, we know that from the textbook now. It says the rules are to identify the name of the anion in the acid. Again, we stated this is our anion right here. Then we're going to change the suffix of anion according to the table and finish the name with acid. So the word we are looking at is oxalate. ATE will change to IC at the ending. So our acid formula is going to be, it's going to be this one up here with the H attached to the front. And then, to the front. And then it's going to change the anion name of oxalate. That would go right here. That's going to change the suffix to oxalaic. And then we're going to add the acid name to produce our final answer of oxalic acid. And that is what we are looking for. So this would be our correct answer of hydrogen being the cation in the front and oxalate being the anion in the second portion.